Hello, and thank you for watching this screencast about solving rational equations. I've got a great set of examples for us to go through, so let's jump on in with this step-by-step process that you see at the top of your screen. Now, I don't always have you guys write down verbatim the processes. I'd rather you kind of learn to use it, so just make a quick mental note of each of these steps and then see how they're used in the examples. Okay. The first step is talking about checking off our knowledge about the domain. Are there any restrictions that would need to be in place? Like what would an x value be that would make the denominator equal to 0? And we want to make sure we exclude those from our answers at the end. The second step, let's see here. I think we're right there. The second step is all about finding that LCD. And we talked before about how that's going to be the more elegant approach then, rather than combining, a couple of fractions and cross-multiplying to solve the proportion. Instead, we want to multiply both sides by the LCD to get rid of all the fractions, to kill off all the fractions there. We'll get a nice, easy equation to solve as a result. And then again, step 5 brings it back to that notion of, hey, are there any restrictions? Did any of my answers generate a 0 in the denominators? Now, that being said, we're going to get into this first example by looking at what the LCD would actually be. I'm going to go ahead and factor each of the denominators, and in this case I just got to factor the third and final denominator. And what I notice is that it contains both of the factors of the other two denominators. So I see an x plus 2 already, and I see an x minus 2, which tells me that the LCD is actually that third and final denominator, x plus 2, x minus 2. All right, so what we want to do is we want to take this third denominator right here, and we want to multiply it by each and every term in the equation. Okay, so we're going to multiply it on the right side, and we're going to multiply it on the left side. Okay, and what that's going to do is that's going to kill off both of the fractions on the left as well as the fraction on the right. Okay, so if I can write that step up, I don't always write this step up, but if I could show you what I mean by that, I think you'll see. So we put a x plus 2, x minus 2 on the top, and you'll notice that x plus 2 cancels out from the first fraction. We put an x plus 2 and x minus 2 on the top of the second fraction, and again you'll see that the denominator, in this case x minus 2, cancels out. And then over here on the third one, we've got x minus 1, x plus 2, and x minus 2. And the entire thing, the entire denominator, again cancels out, leaving us with just x minus 1. So here we've got 2x minus 2. Here we've got 4x plus 2. And here we've got x minus 1. Now that is a much easier equation to deal with because we've now gotten rid of all of the fractions. Again, note in step 4 where it says solve the resulting equation, what we're going to do now is we're going to have an equation with no more fractions to solve. And this should be, where we can just, go to town solving this, combining like terms and the like. So distributing the 2 and distributing the 4, we get 6x, negative 4 and positive 8, so that's plus 4. And then over here in x minus 1, we can subtract x, we get 5x, subtract 4, we get negative 5, so x equals negative 1. And then before I finish the problem and say, okay, well that's my answer, I've got to double check, does that make any of the original denominators equal 0? And if it does, that would be an extraneous solution that I would have to throw out. Okay, it certainly doesn't, so it checks out. This is a good answer, negative 1 being the only value that we got there. Okay, now example 4, we'll jump on into here. Again, this will be a kind of a we do it together example. Example 4, again, I'll need to factor the first denominator here. Looks like it's going to be an x minus 4 and an x minus 1. Oh, I said x, I meant m, pardon me. M minus 4 and m minus 1. And then I notice again that that's the same denominators of the other two fractions just combined. So if we multiply m minus 4 and m minus 1 on the top of each, m minus 4, m minus 1 on the top of each fraction, then those denominators will all cancel out, m minus 4 and m minus 1. Okay, again, I don't always show this step of writing it up there, but for our first couple of times I will. In this case, we're left with m plus 11 Over here, the m minus 4 is going to cancel out, leaving us with 5 and m minus 1. And then over here, the m minus 1 is going to cancel out, leaving us with 3 and m minus 4. Again, it's very quick to get rid of the denominators by multiplying both sides by the LCD. And then it just becomes a matter of combining like terms. We got negative 5 and positive 12, so that's going to be plus 7, m plus 11. So subtract m and subtract 7, we get m equals 4. Okay, now that's going to be a problem. Why would that be a problem? Because if m equaled 4 in, let's say, this middle fraction right here in the original problem, then it would be 0 in the denominator. So I cannot, this is an extraneous solution, I cannot say that m equals 4 or else the whole problem will be undefined. So this example is going to have no solutions because the resulting answer that I got was extraneous. So if I plugged it back in, it would make that denominator 0. Okay, so again, we killed off all the fractions, we solved it, but that fifth step, we are checking to see if any of the values need to be discarded, and then if there's no remaining value, then this equation just has no solutions. Okay, so here's an example for you guys to try on your own. I know we've gone through a couple of examples pretty quickly, so go ahead and pause the video now, see if you can work this one out on your own, and then when you push play, we'll go through it together. All right, so I hope that you had a couple moments to look at this. We'll factor out, as usual, the middle factor here, the middle denominator, that is. And I'm going to multiply each fraction by that. Okay, now in this case, I'm going to try, since you've already had time to work this out, I'm going to try to not put the LCD up top, right? So the LCD would normally get multiplied by all three terms. And notice, by the way, I say all three terms because that 4, even though it's not a fraction, we can make it a fraction if we need to, or we could just, again, multiply by the LCD. So just because it doesn't look like a fraction doesn't mean you shouldn't still multiply it by the LCD. Whatever I do on the left side, I have to do the entire right-hand side. All right, so the y plus 6 is going to cancel out over there on the left, leaving me with a y and a y minus 6. Then in the middle, both of them will cancel out, leaving me with just with a 72. And then over here, nothing cancels out because there was no fraction, so I'll have the remaining LCD in its entirety right there. This is going to generate a quadratic equation, at least temporarily. Minus 6y, 72, and then we're going to have 4y squared minus, let's see, I think that's 144, if I'm not mistaken. 36 times 4. 36 times 4. 24, yeah, 144. Okay. So now I've got, like I said, a resulting quadratic equation. And so let's get everything on one side. Let's subtract y squared from both sides and add 6y to both sides. And then reorder it. So we're going to have 3y squared plus 6y. And then 72 minus 144. Let's see here. 144 minus 72. 4 minus 2 is 2. 4 minus 14 minus 7 is 7. So that's 72. And it'll be negative 72. Each of these is divisible by 3, so I can go ahead and take out a 3 to make the factoring a little bit easier. Y squared plus 2y. And then, let's see here. It's late in the day, and my arithmetic is not, my mental arithmetic is just not there, fellas. So that's going to be 24. Minus 24. Let's give a little bit more space. And then when you guys went through this problem and you factored it out, you got two answers since it's a quadratic. And we want to double check to make sure that both of them, what do you think, 6 and 4? So y plus 6, y minus 4. And so y equals negative 6 or y equals positive 4. You want to check to see is either of those going to be extraneous. And hopefully you notice that that guy right there is extraneous because if I plugged that back in to the original problem, let's say in this first denominator right there, that it would make that denominator 0 and therefore it would throw the whole thing off. So y equals 4 is my only answer for this problem. Hopefully you guys got that as a result. Now, we start shifting gears a little bit here, and it says, now consider that you got a rational function. It says, find the domain of this function. Remember that the domain is the set of x values, so we want to see, are there any x values that need to be excluded? In other words, look for the roots or the zeros of the denominator. And if there are any roots of the denominator, we want to say, okay, well, those are domain exclusions. So in this case, we've got x squared minus 8x plus 15 equals 0. That's going to be x minus 3, x minus 5. So x equals 3 or x equals 5. Those are my two exclusions from the domain. Okay. It says solve f of x equals 1, so I want to set the whole function or the whole fraction equal to 1. So 2x minus 6, and then x minus 3, x minus 5. And it says solve this equation. Now you can solve it whatever way you want to. I would recommend multiplying both sides by that denominator to get rid of the fraction. And since the left-hand side is 1, it's especially easy just to get 2x minus 6. Actually, it'd probably be smart to have this in its FOILed form so we can combine it with some like terms. Equals 2x minus 6. Adding 6 to both sides will make 21. Subtracting 2x will make negative 10. And that's going to look like a 7 and a 3 to me. So x minus 7 and x minus 3. So x equals 7 or 3. Are either of those exclusions from the domain? We said yes. Remember, x cannot equal 3, so that's the extraneous solution there that we would throw out. So we would say for part B, x equals 7 would be that value. And it says find the points on the graph of this function value. And when it says find the points on the graph at this function value, what that just means is that, hey, remember f of x is the same thing as y. So what we just solved was the equivalent of saying, hey, when does y equal 1? So the point on this graph would be 7, 1. We solved when does this function equal 1. So we said, oh, well, when x equals 7. The point 3, 1 would be a hole. Okay, so this would actually be a point, and then 3, 1 would be a little gap, a little hole right there, because the function is undefined at that point. But that's really a little bit more of an Algebra 2 kind of question. Example 7, again, you guys get a chance to do this one, so go ahead and pause the video, and then in a couple minutes, when you're finished answering part A, B, and C, let's rejoin and see how you guys do. All right, here's example 7 worked out for you, part A. Again, we did the domain restrictions. That's where you're finding the roots of the denominator. So hopefully you found 5 and 1. And then in part B, where we set the whole function equal to 4, you solve it out. Now this one factors, you see here in orange. I used the magic method to factor it out. And we find one of the solutions actually is an extraneous solution because it was in our domain restriction. We can't have x equals 1. That would make the numerator equal 0. So that one's a no, or excuse me, the denominator equals 0. So that one's a no-go. But 21/4 actually is our answer. And it says express it as a point on the graph. I went ahead and went to the trouble of graphing this function out for you. And you'll notice right here, okay, that the point that we found is, where we said, hey, let y equal 4. Remember, that's where we're saying here on the y-axis, the curve equals 4 when x, okay, is 5 1/4, where x is 5 1/4, which is what we have there with 21/4. Okay, so good little example for us. And then last but not least here in these a couple of examples 8 and 9 to wrap this lesson up, it says we want to be able to manipulate a formula. Okay, so what I mean by manipulate a formula is that we're given this formula right here, m equals y minus 2 over x minus 3, and we're asked to solve for a particular variable. Now, you'll do this in your science class quite a bit, where you might have one formula like, oh, I bumped that again, pardon me, where you might have a formula like density equals mass over volume, okay, if I'm remembering that correctly. And you might want to solve for volume, okay? And that's a necessary skill for an Algebra 1 student, being able to take a formula and solve for a variable. So let's do that. To solve for y in this case, we're going to have to where we want to get rid of the fraction. We want to multiply both sides by x minus 3. Okay, so whatever I do on the right, multiply by x minus 3 to kill off the fraction, I also have to do on the left, so x minus 3. I would distribute and get mx minus 3m equals y minus 2. All right, and then we've got all we have to do is add 2 to both sides. And so y equals mx minus 3m plus 2. Again, adding 2 to both sides to get y by itself. Okay, manipulating a formula. To get x by itself, similarly speaking here, we would say after having distributed, get that y, there we go. After having distributed the m, I want to add 3m to both sides. I'm trying to isolate the x term right there, okay? So I'm going to add 3m to both sides to cancel it off. And then I've got mx, pardon me, mx equals y minus 2 plus 3m. Divide both sides by m, and then we've got our x by itself, y minus 2 plus 3m. All over m, okay? Now, again, that's just a skill in Algebra 1 and oftentimes in your science classes, physics, chemistry, and the like, where you take an equation and you solve for a particular variable. You take a formula and you get one variable by itself. So with example 9, our last example here in the screencast, I want you to try to get c by itself. So pause the video, work the example out, and then after you've got your answer, check the video to see how you did. All right, so I was going to go ahead and work this one out and then have you reveal it as you push play on the video, but I really feel like we need to see this one in real time, okay? So this is one of those cases where I've got a couple of fractions I need to kill off by using the LCD. The LCD in this case, hopefully you got, was CM. So we're going to multiply by CM times each term, okay? And what that's going to do is that's going to kill off the denominators of each of those two fractions, right? So we're left with M times 1, C times 1, and then Cm. We're solving for C, and there's a couple of C terms. So we want to get those two terms on the same side. So we got M equals Cm minus C. And then here's the trick. We're going to factor that out and be left with, okay, now one C term. Whereas we had beforehand, we had a couple of C terms. Now we factored out. So we're going to divide both sides by M minus 1. This is not an easy problem, okay? So we wind up with C equals M over M minus 1. And where most people trip up, where most people have trouble, is getting two C terms down to one C term. The trick there is factoring it out as a GCF once you get both C's on the same side. So that being said, you guys have a homework assignment on Delta Math where I think I've got 14 problems put together solving various rational equations. Most of them will look similar to what you see in example 5 and example 4 and what we saw in example 3. Please, 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 please be on the lookout. Check for extraneous solutions because you don't want to have to kick yourself for having actually included an answer that was extraneous in the first place. So if an answer makes the original denominators 0, any of the original denominators, you need to exclude it from your solution set. Work diligently on that homework assignment and then come up with some questions for me on Friday. And I appreciate y'all's attention in the screencast.